Okay, so I guess, yep, we're recording now. Before we jump into Owner, I want to take a minute and just kind of go over a few things. Hang on, let me share my screen here. Okay, hold on, share the whole thing here. Come on, share. There we go. Okay, first of all, Justin Chun had written to me and had said he'd like it if I could put the code and stuff for the class online early so that he could follow along a little bit better. And I'm happily going to do that. However, we are now sort of leaving the part of the class where we're doing a lot of coding. So sorry, Justin, but we will be doing a little bit in the future. But now we're going to enter the realm of kind of like how we negotiate different software packages and how we do things that connect things together. Um, and that's what I want to kind of go over with in the syllabus because I finally have it kind of set in my mind. I mean, this class has been a work in progress, and I've really been kind of unsure of exactly where it's going to go. But now I kind of have a sense of what we can cover. But I need to warn you about something. It may fall dramatically out of order, but it won't be bad. Owner has been having trouble with his internet service provider in Turkey. So he's there now, but he had problems getting some things set for the class today. And I'm not sure how long our good fortune will last. So we're going to let him go ahead and start going in a minute. And if it turns out that it's just not going to be workable this time around, then I'm going to jump in and start with some other stuff. What is that other stuff? I want to take you all can see the syllabus, right, that I'm showing? Okay. Yeah, good, good. Okay, so here we are. Owner's going to be doing machine learning 2, and I might actually jump ahead. And the kind of the interestingly out of order thing is going to be Lara's presentation next week. In a sense, she's going to show us the future a little bit because she's doing some things that I want to make sure to get it to next semester when we start talking about integrating Unity and VR and AR into all of this work, because that's when it can become really interesting. And she's actually done some of that work. But she's also had an interesting history, especially using the web as a kind of an artistic and creative platform. So I asked her that she could kind of talk about her work. So she's going to show us some things that, we may not get to for a while, but they're going to be pretty fascinating. All right, then there's election day, and then this will either be a really good class or a really bad class. We'll just have to wait and see. But if it's going to be a normal class, I want to start talking about some very basic stuff, like using the web to just stream and things like that. And I've asked a guy, he hasn't gotten back to me yet, from Yale, who'd done some interesting work with network laptop ensembles to come and talk for about 15 or 20 minutes. And most importantly, I'm going to start this, and we actually may do some of that tonight if Owner kind of flakes out with bandwidth. What I'm going to do is John Levy had an idea for a project that he wanted to do, and I'm going to do an abstraction of that he kind of described, and we're going to use that as kind of our basic operation. The two big areas that we have yet to cover in this class is kind of remote interactivity, or how can we set up something that we can then control remotely. And I'm going to start by building a very basic patch that has essentially two variables that we can control that will affect the sound output from patch, from the code, from whatever. I'm going to show you two different ways of doing that, okay? So that's going to be step one. Step two is going to be, how do we then set it up so that we can control that patch or that code or whatever over the internet, all right? So that's step two. We get that happening, we're happy, all right? Step three, and this is where we then shift to the next week, is how can we hear the output of that controlled sort of thing that we've set up over the internet. And I want to show you, this is the one part that I haven't completely done yet. I want to show you how to set up your own internet radio station so that you can have something going. And you could actually just configure it to play your music all day long if you want to. And people can actually just go to a particular URL like you do with normal kind of, podcasts or something, and they'll hear what you're putting out at that time. So when we put it all together, we'll have a kind of a control system where the controller can access a remote process that's making sound that will then broadcast sound back to you or to the world or whatever. Then we can connect that remote controller to any number of things. We could use machine learning to recognize, you know, number of absentee ballots returned or something like that, and it can like then affect the algorithm, and you know, we can hear the results of it. So that's kind of where we're going with that. The second, that's the one area that we want to cover. And like I said, the only part I don't have kind of completely figured out yet is how we set up this thing. All right. The next big area though, and I'm going to kind of yield the floor to the people that are working with it and have invented it. This is when Miller Puckett and Damon Holtzgren are going to come and talk. Miller has developed this very, very interesting real-time audio interactive system that works over the web. All right, so that's going to be different from these, although at some point we can integrate all this together if we want. All right, but basically this is for people who want to play together, people who want to improvise together and hear like full audio. Apparently it works quite well. It's called Quack Trip, and Miller's going to explain kind of what he did to make it go, you know, how you get it working. Then Damon, who's been using it quite a bit with some of his improvising friends, is going to talk about his work and say, this is what you do to actually make it happen. Okay, then we have Thanksgiving, and we'll probably need this day because I'm not sure how far we'll get with a lot of that stuff, but we'll just kind of shuttle it off at that. So that's going to be sort of where we're going and where we're at. Now, I promised that I'd talk a little bit about the class presentations. Look, you're not going to, if you're here, you're not going to fail this class, you know, and this class is going to be pass fail. If you are getting a letter grade, you'll get an A or an F. The only people who get Fs in this class are people who don't show up, who've registered for it. And that hasn't been a problem here. Your class presentations, it's entirely up to you. You could just talk about what you'd like to do. You could talk about what you're doing. You can show some fragments of stuff. You can finish a full-blown, incredible, interactive web platform thing that's completely new, is going to take the world by storm, you know. But we'll leave it pretty open. If you have questions or concerns about this, you know, as it gets closer, write to me or Onur, and we can kind of, you know, put your fears at rest. You know, again, this is a graduate class. It's a graduate seminar. The other thing is, I realize we throw so much stuff at you. Most of you won't really use this until after the class is ended, because you can't do a project where you don't know all the stuff you can do yet. So yeah, and the final sort of thing here is that I'm intending for this to feed into next semester's class for people who are interested. And that's when we get back to doing Unity with virtual reality, and possibly taking a look at the Unreal Engine, which is another game development engine too. But we'll see, all right? So that's kind of where we are and where we're going. Any questions or concerns about any of this? Good. That's very nice. Okay. All right. And again, for people who are auditing, you could show stuff if you want to. You know, it's obviously you're not required to. Anyhow, at this point, I am going to turn this over to Onur, and we will see how far we can get with the next chapter in machine learning. And again, we're not going to be doing a huge amount of coding from now on, just enough to kind of get us going with some of these platforms. And the real money is going to be, you know, how we put everything together. All right, Onur, take it away.
Hi. How's my voice? Is it okay still? Like, I tried to do a couple of things, but is it in sync at least?
Say something again. Yeah, it's pretty good.
Is it? Okay, so yeah, I mean, my apologies in advance for today. Like my internet service basically just stopped. Like, I mean, I just got it connected over the weekend, and then there's apparently a problem. Like, I'm not getting like fiber optic signal or anything. So it's been like this since morning, and also yesterday it was a little kind of flaky. But anyway, so right now I'm using just like my phone hotspot, but it's throttled right now because I used all of my data before, so we'll see how it goes. All right. So I was planning to do a bunch of things today, including Wackinator, which we briefly talked about last week, and also some Unity stuff. Unfortunately, the Unity stuff probably won't happen because of my internet again. I couldn't like download and install some stuff. But anyway, so we'll start with Wackinator now. Let me just share the screen here quickly.
This is maybe a good lesson for working with the internet. These things can happen.
I mean, the thing is, the speed is one thing, but because I'm using a hotspot, I can't use the OSC. Like I was going to use my phone's accelerometer for some examples. I
Actually,
just can't do it right now because.
Yeah, I'm going to talk about that when we start talking about remote control. We're going to be using OSC, and I want to go into the issues surrounding port mapping and network address translation.
I mean, as long as you have a router, it's not a problem. But now I'm just using my phone, and for some reason, like it just won't let me. It just doesn't take data from itself when it's the hotspot. Like it's just. I mean, maybe there's a way to do it, but yeah. Anyway, so let's take a look at this thing. Okay, so do you see everything, the patch? Should I
Yes.
make it larger?
I would prefer it larger. I don't know how other people feel.
Okay, so let's see.
Yeah, that's good.
Okay.
Remember, if you have questions, shout them out because we can't see everybody now.
Okay. So let's see. All right, so my plan, so okay, so do you guys know, like, do you remember what Wackinator is, kind of?
I don't think we went through it. You might want to go through it. Okay.
Okay, so let me pull up the website as well. All right. I mean, it's basically a tool that makes like using like machine learning techniques kind of in a very like very kind of I would say accessible form. So it's especially like great for like artists and stuff because you don't have to write a lot of code or anything, and it's good for let's say mapping. Let's say you have like this instrument, some kind of electronic instrument. You can easily like map what you do on it to some kind of output without even thinking about like how exactly those inputs are mapped to the output, because the machine learning algorithms in the kind of like in Wackinator do that for you. And the way you work with that, okay, so let's kind of start from the beginning now. I was going to actually pull up the whole like patch that I prepared, but like we can maybe like just build it from scratch. Okay, so the way it works is that you have your inputs, which you send as OSC messages. And then you have your outputs again, which are sent as OSC messages. You can, I believe, I'm not sure what the maximum number of inputs is, but it's pretty, like it's a big number in any case. So what I'm gonna do is that I wanna take my video kind of like input, and I'll show you how actually you map it to, like as a vector here in a second. So, and I want to use that info, basically like info of my face, to control a formant filter to produce like maybe like 5 different vowels that I picked from like I picked the values from this article on like Turkish vowels. The values change from person to person, but I'll show you in a second that actually like you can produce these vowels very easily using these values. Anyway, so actually before I get to this thing, let me just show you what I'm trying to do here.
While Onur's bringing that up, if you don't know what an OSC message is, don't worry. That's what I'll be covering in some detail the next time I talk. So it's just a way of getting information over the network from one thing to another.
Okay, so let's see first if you hear this thing. Right. So do you hear anything?
No.
Oh.
I hear you clicking on the keyboard.
All right, so let's
yeah, make sure the output is going to your Zoom audio device.
Do you hear it?
No.
Oh, sorry.
Yeah.
Okay.
Hear it.
All right, so what I have is an RTC score has two things. I'm not sure we talked about this bus config instrument, or I'm sorry, function. I think we have, but
Doug mentioned it briefly,
of,
yeah. Doug mentioned it briefly.
I mean, basically, the wave table goes into into the filter bank instrument. So what happens is that, so I have this type of buzzing sound here. It's a sawtooth wave. You hear it, right? So this kind of like approximates your vocal folds. It's actually quite like, what happens in your mouth is that the vocal tract, so there's this buzzing sound that comes from your vocal folds, like this, and your mouth filters it, and that's how we kind of produce vowels actually. So if you filter the sound using certain values, and the values that I'm using here are, I'm using 3 formants, so those are 3 frequencies. So okay, they are the center frequencies of, like, let's say a bump in this filter. And then the second value is the amplitude of the formant. That's a little less important for our purposes today. That's why I'm not controlling it in the other RTC in the other max patch. But anyway, so I have like 3 of these groups. So like first formant and the relative amplitude, second one, and the third one. Actually, here I think I'm using 4 formants. Yeah, I'm using 4 here, but 3 is enough. And the last value is the fundamental pitch of the vocal fold. So that's kind of like the pitch of fundamental pitch. Okay. So if I filter the sound with these values, it kind of like sounds like an ah vowel. And then with these values, so it's pretty straightforward overall. So I'm going to be using a version of this here. It's a little simpler. Let's see for a second. So I also added a couple of like fundamental frequencies. Just they're kind of random, just to just so we have like a bit more pitch action going on there. It's not monotonous. All right. So back to Vaccinator. So it listens on this port. It can change, but I'm just using the default port here. And I'm going to be using as input. This is also a nice app. It's called Face OSC. It basically detects your face here and sends a bunch of values. It has a couple of different modes. Let me actually just pull that up quickly.
That looks really scary, Onur.
I had to shave, otherwise it wouldn't like detect my face properly. All right, so just give me a sec. I mean, as you can see, so there are like different types of modes here. There's a pose mode, which sends these values, and then gestures. But I'm not gonna take the easy way out this time. Actually, maybe this is the easy way, but like, so basically what I'm gonna do is I'm gonna send all of the raw info from this into Akinator. So that's 66 XY pairs, so basically 132 inputs. And because I don't want to just by myself like try to find like which values matter here. I just want Akinator to figure out how to kind of like detect which vowels I'm producing at that point. Maybe I should even take my glasses. It looks better like that. Let's see.
Hey, is everybody else there?
Yeah.
Onur, everybody just froze for me for about 15 seconds.
Well, I think that's the internet problems that you were already warning of.
Yeah.
What happened?
I'm not sure it was you, Onur, but I think everybody froze for me. I've been having weird problems getting to the East Coast from out here today for some reason.
Okay, so should I just explain it again?
I don't know. Did you all see? Did you all hear what Onur had to say?
No.
Okay, yeah, you'll have to do it again, Onur. I'm sorry.
Okay, that's fine. I mean, I'm also like barely kind of like
frozen now. The share screen.
Is it?
Yes, it's
It
frozen.
is. Yeah, you're gonna have to reshare your screen.
Oh God.
Sorry about that.
I mean, it's just like already like I can feel like your images sometimes also get stuck. So it kind of, I feel a little weird, you know?
Yeah.
Let's
Okay.
see.
We'll try and let you know when it happens. If it starts getting unworkable, we'll shift to something else.
Can I ask a quick question in the
Yes,
meantime?
please.
Sure.
So you are filtering a single saw wave to produce the vowels, right? Just
exactly.
One. And you are filtering in the sense that are you emphasizing the formants or are you subtracting everything else only to leave the formant frequencies?
In this case, I believe I'm just adding.
Okay, so you are increasing the amplitude of the formant frequencies and everything else stays the same?
I mean, take a look at this thing. So I'll show you something here. So this is, let's close this thing for a second. So you don't see it right now. Let me just share it quickly. Do you see it now? Is it frozen?
I can't tell.
No.
That's good.
Well, actually, it is indeed making some of those things, making some part of the spectrum softer. Like, so it's not. So take a look at the spectrum here.
Yeah. Onur, I think the filter equation will emphasize regions of energy, but will subtract.
Exactly. Yeah.
So it does. It's a combination of both. Yeah.
Yeah. Yeah. This is. Yeah. So I forgot exactly how the filter banking works, but like if we look at the spectrum, it looks like it's doing that actually. Like it's let's see. Yeah. Okay, so so if I choose raw, I will just send these 132 points that it's detecting here. There are other kind of settings here which I didn't mess with so much. I just changed my camera here from the webcam to the internal webcam of the computer because it's easier to kind of. I'm not sure how good this is, but I think it does the job right. So let's see. And I have to match the input message with the output message of the video, which is raw. And then inputs 132. This can stay the same. I'm gonna use the continuous mode. If we have time, maybe I can also talk about the dynamic time warping mode, but let's go with this one for now. And I'll use 4 outputs, which are the first formant, second formant, third formant, and the fundamental frequency.
Yeah, this is all documented pretty well on the Wekinator website too. What he's actually using is the Wekinator app there for those little windows.
Yeah, even the Face OSC app, although it's not made by Rebecca Fiebring, the author, I think it's used in a bunch of examples that you can find like on YouTube. I think Gene Kogan has a video where he uses it. All right. So this is what it looks like right now. We're listening to this thing on this port here. And let's see. Sorry, not this one. Okay, there's something I couldn't quite decide, but I'll show you in a second. We can try both if time permits. So what we're trying to do is we're trying to match those 132 inputs to these 4 outputs. And the way we're gonna do it is gonna be like this. Let's see. So right now, as you can see here, we're getting the OSC messages, but it's not recording anything. So what I'm gonna do is I'll send the values for the vowel. So they're here right now. There are different modes for these things, and I don't know like if one works better than the other in this case. You don't have to specify a range per se. If you go to this edit mode here, so you have 2 different modes here. It could be like floats or integers. That's straightforward, but then you have soft limits and hard limits. And I'm not sure like if we just use soft limits here and send whatever values that we have here, it will train well. Before I use the hard limits, but the kind of like difficult part about hard limits is that you need to understand, like at least like you have to have like a range in mind, you know, for your formants. And the way I did it was I looked at these values from this article that I was talking about with I think it's this one here. So what I did was I quickly took a look at all these values here for, let's say, the formant 1. And I picked like the lowest value here and the highest value here. And those two numbers became my like minimum and maximum. But maybe we should just try it with the soft limits right now and see what happens. Can you see the screen now? It's not frozen, right? All right, great.
Okay.
All right, so, okay, let's keep it like this. Okay, so here's what I'm gonna do now. I'll make the, I'll pronounce the vowel, and while I'm holding it, I'll start recording and then end the recording. So that's gonna be my input for this particular vowel here. But mind you, the program is not listening to the sound. It's only like seeing me. So let's see how it goes. Okay, so so and then let's now I'm going to send the values for this one here, so just checking if everything is in there. They are. Okay, so let's do it now. So those values are also recorded now. On to E. E. And then an O. O. And then U. Ooh. Okay, I think we have all the values now. So what I'm going to do is I'm going to train now. May take a while.
Yeah. While he's training, I just want to point out the obvious is that you can use this for any input. I mean, Onur's using his face. He could have like used hand gestures, or he could have like looked at
exactly.
his feet. Yeah. So this could be, or he could have used like data from the internet. Any number of things.
And I have a joystick here, which I'm also planning to use in a second. So you can also like use a joystick, anything, like any input is fine. This is a particularly interesting one because it's a lot of inputs. That's the kind of the interesting thing here. Or let's say it's a more challenging situation because with like less inputs, you can, I mean, there are certain things you can do by yourself. If you have only like 3 inputs, probably you can map those things easily. But if you have 132 inputs, that's not so easy to kind of map to 4 outputs. So if you have like an algorithm that does it for you, it's great. Well, let's see how well it works.
Looks like it's kind of a slow learner today.
I mean, it's a lot of data, you know. I'll show you, for instance, if I use a joystick, it just trains much faster. So.
Yeah, I think we need to incentivize it.
But anyway, I mean, if you have questions right now, I can answer them. Maybe like, I think I'm kind of going a little fast, maybe, I don't know.
Part of the fun of the Wekinator is that you can learn it just by kind of using it. For the web page for this class, we're going to include all the stuff that Onur's got here. I did a much older class, well, much older, it was like from 2016, where I did recognize gestures and I mapped them onto that. There's a thing called the Leap Motion Controller. It's kind of like a mini version of the Kinect. And I was actually having it control mixes so I could wiggle my fingers and have things go up and down. It kind of worked, but anyhow. So we'll put all that stuff up there too, so you can take a look.
Also, I mean, it's a small thing, but it's kind of, it matters a little bit. If you want to make your like vowel sounds a little more realistic, you should add a bit of like vibrato. It just completely kind of like elevates the sense of like realism, you know, in the kind of synthesized like voice, you know, so.
Unless you're really into pitch correction. The other thing Rebecca has, you can actually use different algorithms for doing the learning that you can choose from the Wekinator. She probably goes into this in her course in more detail. I frankly didn't know the difference between the different models that you can check. And I didn't detect it.
We can talk about them later.
Okay, good. Sorry, I'm jumping the gun.
No, that's fine. It's there's also like this classification like kind of algorithm, which may actually work better with certain things, but the continuous one is nice because it can also kind of morph from one kind of value to the other, which I think is nicer for if you're trying to kind of get some interesting sounds and not just like detect something and like trigger stuff. I mean, this will produce some stuff that we haven't planned ourselves. So that's why I want to start with this one.
One of the early examples when they were first developing this, when Rebecca was still at Princeton, is they had an installation where a student had basically shot a camera looking down on a snake. And as the snake kind of snaked around, it would recognize different configurations and use that to trigger musical events. So that kind of shows you what you can do. Like when the snake was like this, it would go or whatever. Kind of fun, kind of cute. Very snaky.
Okay, yeah, we're done. Great. So when these things turn green, you're done. All right, so let's hope for the best now because I haven't tried the soft limits with this one before, but if it works, it's great. It's less work for us. Okay, why am I? Let's try this again. Okay, let's try this. I mean, it's not perfect, but it works.
That was pretty fun.
I mean, you can train it more, by the way. Like I only recorded one example of each, you know. If I record more stuff, then it'll be more accurate. But
was the hard limits
it's quite
version
impressive, actually.
right? Was
What's
the
that?
hard version, hard limit version that you did, was that better at tracking?
It wasn't actually. It wasn't better, I must say.
Interesting.
But yeah, I can't tell right now because yeah, I trained it a little more than this one. I recorded, I believe, like 2 or 3 examples, but I can't. It wasn't significantly better, I think, in any case. But I mean, this is I think workable like completely, because with that one I need to like, you would need to find the hard limits, which is, I mean, if you have 6 values for each formant, then it's fine. But imagine having like 1,000 values somewhere. You can, I mean, you can find it easily. I mean, you can just sort them in some way, but this is just less work, you know. And I believe it works. I think it works fine overall. I want to try. Okay, let me just try quickly something.
The other thing Onur mentioned last time is once you've trained it, you can save all the values of the state, so it doesn't have to retrain. You can just load it right in and it's ready to go.
Yeah, exactly. So so let's say stop running here, save project. Let's see, browse. Okay, save as
Has anybody written something to learn formants for individuals? Like,
can you say it again? I didn't hear you properly.
If a neural network knew what words you were trying to say, it could learn your formants, right?
Yeah, I think Ben. Yeah, I think you'd have to.
Hear you, sorry.
Okay, I think you'd have to do some pre-processing of the signal and abstract some of the gross features. Certainly the Wekinator wouldn't have enough inputs to look at like the sample stream directly. However, some things like Google's TensorFlow and others like that, I think, can handle that much data.
Sorry, Ben, I couldn't. But I guess you asked about the was the question about individual samples?
Well, Ben was wondering if you could train it to recognize formants in an audio stream, so you could tell what vowel a person was enunciating. That's the gist of the question, right, Ben?
Yeah, and learn, like, I assume everybody's formants are different.
I mean, but there's commonalities. Yeah. Go ahead, Onur. You know this better.
Of course, but like even 132 kind of inputs, I would say, is a lot for. I mean, I'm not saying that it can't process it. I'm not sure like what the limit is for Wekinator, but it kind of defeats the purpose of this program, I think, to have that kind of thing. That's more like what was it, the WaveNet examples? Maybe some of you know about those. Like they are complete sample based, but that's a lot of processing power, and that's like it may take quite a long time to train, you know, this particular one with so many samples. So, but in theory, it should be possible to do it if you can somehow slice it up.
Well, I mean, they are doing it. I mean, that's how Alexa and Siri and all those work. You know, they're recognizing stuff like that. So they've got some, in fact, I believe there's probably some trained models down there that you can just download and use. I don't know that much about this area, but Onur, you probably do.
I mean, you have all these like Python-like libraries, like the Google speech recognition library, for instance. It's just basically plug and play. Like it's been trained probably like billion times anyway, so you just it just sends it to whatever you say, it just sends it to Google in a couple of seconds. You just come, you know, the transcription just comes, you know, to you. I'm not sure if I have an example of it here. I used to use it for controlling my gadgets at home, but it's pretty good. So it's possible, but I wouldn't use Wekinator for that.
Mubo has a pretty nice application for that also, this earcom package for Macs.
Yeah. Hey, Onur, you got a couple of questions.
I'm
train
looking
it
at the
on
questions
your-
right now.
Sorry, Nicola. Go ahead.
Were you asking something, Nicole?
Yeah, I just wanted to say this idea of like training a model for like vowels. I mean, then of course it doesn't come with a database, but this Mubu software package from Earcom for Macs can do that quite well.
Yeah.
And it
Yeah.
actually comes also with the implementation for movement, so it's sort of built for the bridge, but you can basically use it for movement and for sound.
Nicola, could you send me that link and I'll put it on the webpage too, so people can look at it. Hey, Onur, you got a couple of questions. Laura wants to know
Yeah,
what the name of the face tracker was. I think it's Face OSC. And
Face
Yoshi,
OSC.
yeah, and Yoshi wants
I mean,
to know.
I'll send over. I mean, basically, we're just gonna put all these links up, soon.
Right, and
Don't worry about it, but
right, sorry. Yoshi wanted to know if there's much latency, and I said it's very fast. Once you get it
it's
trained.
very fast. I would say it's once it detects, like there's hardly any latency between the output from Face OSC and the input in Max. So.
Yeah.
But I believe like you may have heard some latency, exactly like you said, because I think my audio is not in sync. So, but take my word for it. It works fine. Any other questions here? So, okay, so what it does when I'm not trying to make a vowel, I don't know, let's see what happens. Okay, so. Oh, sorry, it's not even, okay, sorry. Okay, so probably because we don't record enough examples, it may have generalized also my location, the exact kind of location of my face in the screen may have also become a data point in itself, for the algorithm. So that's possible because again, it just doesn't know what to look for here. All it has like 132 like points that are somehow like connected to one another, but we haven't specified what exactly is the connection between them. But I think at this point, we just don't know exactly what it's looking for. But indeed, it reacts to the vowels. So that much I know. So.
Poor thing was trying so hard.
I mean, it's actually remarkable that like it can even do this thing with like one, like basically one example per output. All right. Okay, we can just use like, I mean, now I can show you a sample with 2 inputs this time, but we can still use the same outputs. But that's going to be less interesting because, anyway, let's do it for the sake of kind of seeing it. Okay, close this project. I mean, the joystick I'm using is something like this. It's just a normal, where is it? Yeah, sorry. Which, okay, I'll just close this thing for a second. So now I am using 2 cameras, so I'm a little confused here. Okay, so that's basically it. I mean, it has all like axes here, different ones, but I'm just going to be using like the main kind of axes, like so the XY axes. Okay, so I'll share my screen again. Okay, create a new project. For outputs, I'm just going to use the default OSC input message here. For this, I'm just going to be using the HI object here, just for interfacing with controllers. And I'm choosing my joystick. Let's poll. Okay, so it looks like we're getting data from here. What I need to do is, I mean, I didn't talk about this patch so much. Maybe I should do it very quickly. Basically, you need to use the UDP receive and UDP send objects here, and this is the port that it's listening to here. This is for the outputs.
Right, and we're going to be going over that. We're going to be going over this in great detail in a future class too. I'm going to explain what these ports.
I mean, this is just going to be very quick, you know. So, and this is how I send data to Wakinator. Whatever is sent needs to be prepended with the OSC specific OSC message. In this case, this is to set the outputs during the training stage, because normally Wakinator sends the outputs, but these are just for specifying the outputs here while we're training it. And what I'm going to do is that I'm going to route this guy to the inputs. Did I delete that? You can just go here again. Doesn't matter.
When is that to go to the inputs or the outputs?
What's that?
I think you just routed it to the outputs, didn't you?
No, this is the input. UDP send. So I'm just sending the data right now for training. But
I see. I'm sorry.
Just a joystick. Joystick data needs to be there.
Right. I understand.
These values, the formant values, will be sent to the output.
I see. I understand.
Not to the output, sorry, but like it needs to be sent to Wakinator. But it's just for, I can actually do it myself. So I mean, I can set these things myself here, but it's just easier to do it like this because I have it set up.
I got it. I was mistaken because of the UDP send next to it. I thought that was going to some other part of the Wakinator or something.
Yeah. Okay, so let me just see if, why is it not receiving these things? Oh, okay. Interesting. Oh, it's okay. I get what's happening here. I don't even need this right now, so I'll just put here. That's interesting. Oh, sorry. Of course. I don't know what's up. Okay, so Stack Overflow. Alt is disabled. Okay, that's fine. Guess. Okay, great. That's fine. So let's send these guys here. Okay, so now we're getting OSC. It's basically just XY values, nothing else. So let's set, so let's start with A. So I'm just gonna pull up for A. So A. So this is going to be, let's say, this is going to be forward. Stop recording. Okay. And then E. Let's make this, I don't know, right. Well, I don't know why it's doing this, but anyway, probably it's just the way the joystick sends data, but anyway. And then let's do, so let's make this left. And ooh, I don't know what. Maybe kind of diagonal, like upper right or something. Oops.
So basically you're moving the joystick to different positions and then you're going to use that to map to the vowels?
Yeah.
Got it.
But I mean, we'll end up with like some weird sounds as well in the process, I think. So train, this shouldn't take too long, already trained, as you can see. So let's try this. Okay, so this is, it's not perfect again, but you can get some like weird sounds out of it. So I could have trained it more and like, I could have made sure that like, it understands like where exactly the joystick kind of like position is like with these formats, but that's not the point, you know? So it basically kind of like learns something and does it. And I think it was close enough to what I did here. I mean, you can't see the joystick, but-
Can you show us the joystick while you operate it, or is it not long enough on the cable?
Oh, well, let's see. It's not about, yeah, let's try it. Okay, so here. Actually, let's train it once again, maybe quickly. Okay, so what I'm gonna do is actually, let's do like this. Instead of like starting with the position right away like this, I'll actually move the joystick to the position after I start the recording. So let's see what happens then. Could be a little more accurate, maybe. Okay, so let's start with this one again. Back. A.
There's ways you can even set up a timing on the start and stop recording if your hands are getting like crazed.
Do you mean via Max?
No. It's actually in the Wekinator, if I recall. You can actually set it up to do a timed recording, so that you don't have to like try and like manipulate the mouse and the joystick simultaneously.
Okay. What I did was I used some commands inside Max. I mean, from Max, like you can send OSC commands to actually start and stop these things. I tried it with another type of training, but anyway. But in this case, it doesn't matter, I guess. So where were we? Oh. Then U. Train. Already done. Let's start this guy. It didn't work this time. I think it's because it's also registering the return to the center as an input in this case. Okay, this didn't work quite well. Let's do the stuff. Let's do the thing before we did before. Right,
there's a one-track mind.
There's another type of training which takes time into account as well. So like basically your move from center to left, let's say, or whatever direction. It's registered like also like on a time axis. Okay, so let's not do U this time because I think it can also, because it's a diagonal kind of position, maybe it messes with the training a little bit. So let's do it like this. Train, run. Right, let's start this guy first. Yeah, I don't know. It's for some reason I think it has something to do with the fact that the joystick is not sending inputs indefinitely. So when I put it into one position, for instance, it stops sending the values after a while. So I think if I maybe keep moving it, something like this, for instance. So if I do this and just wait, it doesn't receive inputs anymore. Maybe I should do something like this, like wiggle it a tiny bit. Then it could be better. I don't know. Should we try it?
What else you got to show? We got about 40 minutes left in class.
Oh, time flies.
This is working.
Okay. All right, let's close this thing. There's another type of training. I was trying to do something, but I think it didn't quite work. But depending on the results, we can simplify it a little bit. Okay. So there's other type of training here. So dynamic time warping. So 5 gesture types, which would be in this case, different vowels maybe. And then as inputs, I only need 2 because I'm just gonna write, just gonna like basically write the vowels or any kind of sign that may point to them. And all I need is an X and Y because it will detect them like in a kind of, it will take time into account as well. So. So this is a different type of interface, as you can see. We don't need to train it separately. The training phase takes place like while you're doing it here. Sorry. Okay, so. Just trying to okay, so now you can see both, I think. I mean, if this doesn't work, I'm not going to try to debug or anything because I have, I can also show you the Unity stuff, at least a part of it. But let's see. Okay, so we have these guys here. Basically, what this does is that like it tries to match a certain gesture that you teach it, and it just tells you. So after you train it, let's say, and let's say I draw. Let me show you something. For instance, oops. So. Okay, so I'm going to put it in the training mode here. So it already added this example. More. So as you can see, like I'm adding more and more. And then the second letter. So again, here, let's do 10 of each. Third one. All right, so now let's give it a try. Okay, so there was a time it would work, but I think I recorded like, I don't know, maybe like 100 examples of each. For some reason, it's not great. This particular thing is not great with or unless maybe I'm doing something wrong. It's not great with like very complex kind of like gestures when you do it like this. Unfortunately, I couldn't get it to work, this one.
I'm surprised it's not. I'm surprised it's not putting anything out at all. You know.
I mean, it is putting something out. It's just that it's not putting the right thing out. So if I do, okay, so let me just quickly do this thing. Sorry, so. Okay. It's not even receiving these things for some reason.
Yeah, that's what I was noticing.
Well, I know why. It's because okay. So what I'm gonna do is this. Okay, so let's stop this for a sec. Okay, so let's try this. This is weird. First, this should be like the easiest one. Okay. Yeah, I don't know why this is the case. I got it to work sometimes. It's a little kind of, I don't know, maybe like, I just, again, when I trained it more, it worked better. There may be some tricks to kind of make it detect these things better. I don't know.
Is that one time dependent? So depending on how fast or slow you make the, you draw the vowel, will it change?
It may have something to do with like, there are some parameters here that I can change. Let me just show you, for instance, these ones, for instance. Also, there's this one, where was it? So matches compute continuously while running. Actually, this I don't want. Once running stops. This could be better for me because it will wait until I'm done with the letter, or I can just force it to kind of like stop running. So, okay, so let's see. But it still doesn't do it. It's still kind of like computed before I'm done. I don't know why it does it. Anyway, when I get it to work, like I'll show you again, but this is the idea, you know, it learns to classify whatever you do. It probably works better with like more inputs.
Okay, just to let you know, we do have a request to see some of the Unity stuff, if you're able to show any of it.
Yeah.
Okay.
Okay, so that's this one. Right. Yes. Okay, I'm just gonna go over basically what I did was I think like now they have like better ML tools, but this was the first iteration of their ML agents. What I did was I kind of like trained some of these models myself just to see like how well they work. So I can show you a couple of things right now. Okay, so.
Question, what is an ML agent, from Anthony Dean?
I mean, Unity came up with these basically like they made it easier for people to use machine learning. So they combine like TensorFlow, that's Google's machine learning library, with Unity, and they just basically created this this like workflow, if you will, where you can easily train these agents to do stuff that you want them to do. And actually, there are a couple of things here. Last week I talked about some like machine learning techniques. Maybe now I can show you like exactly what they mean, you know, with these things. So let me actually pull up also the link here. So it was, let's see. Oops, not here. Anyway, so just write this thing in you. I mean, I will post all the links, but this is what I kind of what I tried. I think, like I told, now they have better better tools, but this already was quite impressive for me. And I'll answer your questions in a second, but like let me just first run these things quickly, and then certain things should become clearer. Just give me a sec. All right. Academy. First, I'm going to start with their own kind of like training data here. So what's happening here is that these guys are trying to balance the balls here. But this is already quite trained. Let me just try to find something. Okay, so unfortunately, I can't get into like the whole like training procedure right now because my TensorFlow doesn't work right now. I need to do something about it, maybe like recompile it or something. But what I did was I trained at 500, like this is only like a training of 500 iterations. And you can see that it's actually kind of not doing the job well. And then here we jump to 1,000 iterations, or was it 10,000? Yeah, 10,000 iterations. As you can see now, they know how to balance the ball. I mean, I can just basically just, let's see, show you not the training procedure, but the tools quickly.
And this will be going into in some detail next semester too, I think.
Yeah. I mean, when I get it to work, like I can actually show this thing in a little more detail over the next couple of weeks if we have time. It's actually quite interesting, the whole thing, when it works. But basically they have all these, they have this Python environment. It's like a notebook. And then you can use it to, it basically interfaces with Unity in some way. And it uses some kind of reinforcement learning, the type of like learning I talked about here, for instance. They don't know exactly what to do these things. Like when they first start, so let me just show you that thing quickly again. So the only info they have is actually like, they know when they balance this thing, let's say, when the ball falls, it's a punishment. And when it stays, it's a reward. Whenever they do something that they think is going to lead to a reward, like that's how they kind of make their moves here. And this is called reinforcement learning here. And then you don't tell them how to balance the ball. It's just, they have to learn it through this mechanism. You know, they do something, the ball falls, and you do less of that. And if the ball stays, you do more of that type of thing. But in the end, they figure out how to balance the ball here. And like I said, I use TensorFlow to do that. Basically, that's in Python. Let me show you a more interesting one, I believe. So don't save. So here we have two agents. One can be like human or something, but let's see, agent is in brain. Okay, so let's see. Now I'm gonna play here. So the one on the left is me. I'm not very good at this thing, as you can see. So we can use, both of them can be agents, and then during training, they actually compete against one another. So that's the adversarial networks. They basically kind of take their input from one another. One's failure is, and the other one's kind of like a success, you know. Let's see.
So they're zero-sum ping pong players, huh?
Okay, TF models. Okay, so I'll just put tennis brain here again, and let's check again what's happening. Huh, okay, this also. Why is it not working, this one? Let me just quickly check again. Tennis brain. Oh, my brain, that's fine, okay. Okay, so both of them are ML agents right now. So now they're playing by themselves, but they're not very good at it, I believe, at this point. Actually, it's not too bad. Okay. So also, here's what I did here. First, I trained it, I don't know how many times, like only a couple of times maybe. Unity tennis. And then, yeah. They're not very good at it right now with like very little training. And then after.
Oh, no, there's no difference between the two agents, correct?
Right now, no, but you can actually have different agents, like agents of different capabilities, you know, so that's entirely possible. So this is after like training like for 1 million iterations. Oops, now they're too good. Oops, no. I think it was this example, after training a little too much, they got worse or something. Okay, so. Okay, sorry, I've lost track of which one exactly was better, but anyway, it just, I just wanted to show you that, like, you know, different, like if you train it more or less, like there's not necessarily like a one-to-one correspondence also between like training too much and stuff. Sometimes at some point it may get worse.
Right. I got a question for you. Setting up the training and such for this, is it similar in a way to the Wekinator? Are you looking at inputs that you're going to map to outputs, that kind of thing?
No. No,
it's different
no.
then. Hey? Okay.
It's different. It's different. It's a very automated process. You just need to specify the ultimate aim. In this case, it's winning, and you need to specify what winning means. And then all of the moves are then calculated by the algorithm. They need to figure out how to win themselves.
Okay.
And that's the nice thing about it. You can easily like use these in a game, for instance. Like if you're making a game, if you're trying to make some kind of an AI, these are great. Like I told you, like one of these brains can be you, and then it's just basically a computer game where you're competing against.
Is that how TensorFlow works in general too? Is it that kind of setup? Because I don't know anything about TensorFlow.
It doesn't have to be like that. It's I mean, it's a library. It can be used for many types of training. It's a very general purpose library, I would say.
Okay, so it's not, Wekinator is more of a very specific kind of thing of mapping the inputs to the outputs.
Yeah, Wekinator is a graphical tool. You know, it's TensorFlow is completely. I mean, TensorFlow could be running behind Wekinator, for instance, that kind of thing. There's also PyTorch. That's Facebook's ML library. I mean, I can just give you the links right afterwards. Like we can just put them on the website.
Definitely, yeah. Send me all the stuff and I'll put it up there.
But anyway, I think once I kind of get it to work and once I'm like able to download stuff properly, over the next couple of weeks, we can actually take a look at those things like in a little more detail.
Or we can look at it next semester too when we get to it. So either way, yeah, we'll see how we're doing on time with this class. I think we're going to be in pretty good shape though.
Yeah, just one kind of like a simpler example here. Not this one. It's just, this is a good example of reinforcement learning actually, because what it's basically, so there's this ball here randomly kind of like spawns somewhere. And then all this tries to do is to reach it. And we don't like, I mean, of course, like there are more algorithmic ways of also doing this as well. But in this case, it just basically does like learns it by itself. And if I can remember it. All right. I mean, I'm not gonna get into like Unity code, but it's kind of like a simple code, you know, like with these ML agents, you can easily like create these things. It doesn't take much time. I was actually gonna also use some RTC mix here, but maybe again, like maybe for the, I mean, you're gonna do that quite a bit next semester anyway.
Yeah.
But
yeah.
time permitting, we can also try it in the upcoming weeks.
Yeah. Right. Yeah. There's some trickiness about Unity audio going into Zoom. That, yeah, I have a solution, but it's not an elegant one. I'm going to see if I can't make it better. Cool.
Okay.
Okay. Actually, I forgot. I want to share one more thing with people before we call it a day. So if you want to stop sharing your
screen. Are there any questions, by the way?
Yeah. Let's answer
I can't see the questions
first.
Right now.
Yeah. Yeah, I think we answered most of them as they came up during the discussion. Anybody else have any questions or comments about this so far?
Okay, I'm just looking at the chat right now. Yeah. Okay. Again, I'm sorry about today. It's been a bit of a kind of.
Actually, it was great, Onur. I don't think you have anything to apologize about. Good grief.
No, sorry. Like this was supposed to be like I was supposed to kind of like show you like coordinates and all like these little things and like proper like descriptions of the code and stuff. I'm actually kind of sad that I couldn't show the Unity stuff in a little more detail. That's
well, again, that's in the future. That's going to be in the future too. So I'm not too shut down by that. The Wacanator, I think that was kind of fun to see. So.
The Wacanator stuff, actually, the better ones were the ones where I used the accelerometer. Unfortunately, like those really work beautifully, like very, very nicely.
Yeah.
But maybe next week or something when you show, let's see. I'll once I have my router kind of when it works and it's easy.
Right. Yeah, there's some trickiness. We're going to be talking about the problems with routers in a couple of weeks. So stay tuned. Yeah, let me show. I wanted to show you guys something that just interestingly was in the news this past week. Okay, hold on a minute. Share. Okay, here we go. I happened across this. Google introduces song matching via humming, whistling, or singing. And look, it's doing machine learning. What do you know? So essentially, if you have a song stuck in your head, you're supposed to be able to use your iPhone or something, and you can hum it, and Google will tell you what song it is. Yeah. This
actually,
is
there was another company that did this thing a while
Shazam.
ago, like many years. No, yeah. Shazam only. I think it needs to listen to the actual thing. There was something else I forgot right now, but I remember using it. And when I hummed, it would sometimes, not all the time, but sometimes it would actually give the results. But I'm sure that Google's version is much better.
Yeah, until they get broken apart by the antitrust lawsuit. So.
Onur, are you talking about SoundHound?
Ah, that's probably what it is, John. Yeah.
I'm sorry, like I couldn't hear you.
SoundHound.
Voice. Yeah, exactly. SoundHound. Yeah.
Yep. Yep. That was it.
Exactly.
Anyhow, fun things you can do. All righty, gang. Well, we're close to the end here, and yeah, Onur, again, I thought you did a great job. So next time we'll hear from Lara and see some pretty cool stuff. And yeah, I'll get everything put up on the webpage soon. Let me stop recording here. Bye, recording people.